Continuing with the previous example, instead of looking specifically at 4 or 5 rectangles, let's see if we can generalize and find out what the areas will be if we use n rectangles. Let's focus on upper sums for now. So to find the area, the total area of the rectangles, we need to find the area of each rectangle. And for each rectangle, we need to know what its base is and what its height is. Let's work on the base first. So we want to take this interval from 1 to 3 and cut it into n equal pieces. Let's see what the width of each piece will be. To figure that out, we need to take the total width of the interval. So I take the right endpoint minus the left endpoint, 3 minus 1, and then I'm going to divide that into n equal pieces. So that means that the width of each interval is going to be 2 over n. We're going to call that delta x, and delta x represents the width of each rectangle. Now to compare back with the examples we did before, if n is equal to 4, then the width is 2/4, or 0.5, which was the width for 4 rectangles. And when we used 5 rectangles, we had a width of each rectangle being 2/5, or 0.4. So this formula agrees with the 2 examples that we've done so far. The next thing I want to do is to figure out what these endpoints are. For example, when we did 5 rectangles, we had 1, 1.4, 1.8, and so forth. I want a formula for what the endpoints will be. So let me make a little recording here that delta x is equal to 2 over n. And then let me erase over here a little bit. So let me expand that interval from 1 to 3, just so that I can write in it a little bit more clearly. Say here's 1 and here's 3. And let's say that we're splitting this up into n equal rectangles. So I'm going to add some points along here. I'm going to think of this left endpoint as being x of 0 or x naught, and then x of 1, x of 2, x of 3, and so forth. And somewhere along the way, I'll have x of I, and then here at the end, this is x of n. Now, rectangle 1 is going to be sitting here, continuing along. Rectangle I is going to be the one whose right endpoint is x of I. Just like the right endpoint of r sub 1 is x sub 1, the right endpoint of r sub I is x sub I. Now, the distance from each point to the next is going to be equal delta x. So moving from point to point, I just have to add delta x, and so forth. So if the left endpoint is 1, the next one is going to be 1 plus delta x. Then the one after that will be 1 plus 2 delta x, and then 1 plus 3 delta x, and so forth. Because to get from x naught to x3, I have to add delta x 3 times. So if I want to get over to x of I need to add delta x I times. So this point will be 1 plus I times delta x. So we can write a formula for that. X of I is going to be 1 plus I times 2 over n. I think that for doing algebra, it might be easier for us to turn that around and write that as 1 plus 2 over n times I. And notice that this represents the right endpoint of rectangle r sub I. So delta x equals 2 over n. That's the width of every rectangle. And x of I which has formula 1 plus 2 over n times I, is the right endpoint of rectangle R sub I. So I'm just going to draw that in here. Here's x sub I. Let's call this rectangle R sub I. Now let's see if we can find the height of rectangle R sub I. Since we're going to use circumscribed rectangles to get upper sums, the height of R sub I is going to be what I get when I plug this right endpoint into the function. So the height of R sub I is f of x sub I. So to preview what we're going to be doing next, if we were to have this table for upper sums, then across the top we would have height, base, and area. Eventually we would be down to rectangle R sub I. The height of R sub I is f of x sub I. The base is delta x, and the area will be f of x sub I times delta x. So this is the expression that we're building toward. The area of rectangle R sub I, the area of this rectangle, is going to be the value of the function at the right endpoint multiplied by delta x. So what we're going to do algebraically now is substitute x sub I into the function f and then multiply by delta x. I'll get started on that now, and then we'll continue it in the next video. So f of x sub I is going to be what I get when I plug this in to f. So that's 1 plus 2 over n times I squared plus 2. Multiplying this out, I get 1 plus 4 over n times I plus 4 over n squared times I squared plus 2. Notice here, if you're not able to multiply that out in your head, what we're doing is taking 1 plus 2 over n times I and multiplying it by itself. So FOIL that out, and this is what you want to get. The only two like terms are the 1 and the 2. So this is 2 plus 4 over n I plus 4 over n squared I squared. And that's the formula for the height of R sub I. So the area of R sub I is going to be the height times the base. So that's f of x sub I times delta x sub I, times delta x, which is 2 plus 4 over n times I plus 4 over n squared I squared multiplied by 2 over n, because delta x is the same as 2 over n. And let's distribute that 2 over n. That gives us 4 over n plus 8 over n squared I plus 8 over n cubed I squared. Now that's the area just of this one rectangle. If I want my total upper sum, I need to add up the areas of all n rectangles. So the upper sum is going to be the sum of the areas of the r sub i's as I goes from 1 to n, since there are n rectangles. And that's going to be the sum, I equals 1 to n, of 4 over n plus 8 over n squared I plus 8 over n cubed I squared. And in our next video, we're going to continue working with that formula.